This is Jun2010 A21. Figure 4.1 illustrates an experimental arrangement to investigate resonance and damping. And it consists of a string, which is a pulley, and a spring attached to it. It's got a pointer, which is touching a meter ruler, and a mass. It's made to vibrate by this rotating piece of apparatus. It's called a cam, and every time it turns over, because it's oval shaped, it'll make a bump on the string and it'll cause the string to vibrate. So it's going to do that twice for every rotation. The apparatus, so I've explained about that. The rotation frequency of the cam can be altered using a signal generator, so you can make it smaller or larger. This apparatus is used to demonstrate resonance. Identify the components that are forced to vibrate. So obviously it's a spring and the mass which are being forced to vibrate. And then identify the component that's causing the driving force, and that's the cam, or the rotating cam. Label the vertical axis of figure 4.2. Sketch the shape of the typical resonance graph for the system as the frequency of the cam is progressively increased. So as it is increased, eventually when it reaches the natural frequency of the spring and mass, then you're going to have a larger than normal amplitude, and so you're going to get a graph of that shape there. And there's your natural frequency. Suggest a practical method of increasing the damping of the experimental system. So you could place in oil or water. I just put in brackets here the mass and spring. Or what you could do is put a piece of card between the spring and mass. I would say of large surface area. Between the spring and the mass, and it's perpendicular to the direction of the oscillations. Maybe do a wee sketch if you are going to say that. And so there's a wee sketch, and there's your piece of card there. Like that, and that will damp your oscillations. On figure 4.2, sketch the resonance graph expected for a more heavily damped system. Clearly label this graph D. Now, this is where I was saying that in later years they had started to suggest that the peak of the graph should move a bit to the left, and this is what we would always have said in the books. It's moved to the left and it's a much wider response. So there's your peak there now. And you have to label it D. And in places, if you don't label it, you lose a mark. Resonance occurs when the signal generator frequency is 16 Hz. That is, the oval-shaped cam makes 16 complete rotations every second. What's the natural frequency of the system which has been forced to vibrate? Now, 16 complete rotations means that it's hitting the string twice. So every time it rotates once, it has actually made the string vibrate twice. So its frequency must be double 16, which is 32.